When this class is over, this recording will take a few minutes to process, but then it will post right to our Teams page, our Teams channel, and you'll have access to it there. All right. There was the calculus lesson I did earlier today. 10.2 notes. Let me clear this page. I went through some great detail in that video too. I was so frustrated that it didn't save. Okay, you should have printed out blank notes for this. If you have not printed out blank notes, then you should be writing this on a separate sheet of paper, or wait and come back and watch this video later. I am going to take attendance live attendance here at the end, roll call at the end before I sign off to make sure that people were still on here with me. All right. Since this is live, if you have questions as I'm going through, feel free to chime in. All right. Here we go. 10.2. The topic is arithmetic sequences. An arithmetic sequence, you might remember from your earlier classes, maybe, I don't know, 7th grade, 8th grade, maybe even some in geometry, or algebra, not geometry, sorry. Arithmetic sequence is a sequence where to get the next term of the sequence, you add the same value every time. That value could be a negative, and so it seems like you're subtracting a value. But if you add a negative, it's the same as subtraction. The value that you add each time is what we call the common difference. And that is because the difference between any two terms along the sequence would be the same number every time. For instance, look at this sequence here. We go from 142 to 146, from 146 to 150, 150 to 154. It's clear to see that in order to get to the next term here, they added 4. And then they added 4 again. And they added 4 again. So if you were to subtract 154 minus 150, you would get 4, the common difference. That common difference is referred to as D. So here, the common difference D is 4. All right, very simple. The idea here does not have to be complicated. We don't have to make this overly weird. It will seem complicated, but the complications come in only in the notations, I think, not in the concept. The concept here is easy. Just to get from one term to the next, what number are we adding or subtracting, if you would? In this one, what number am I adding or subtracting?
3.
3. So add 3. I heard it from a couple of people. If I just keep adding 3, the common difference must be 3, right? And it has to be consistent. It has to be the same number every time. I can't add 3 and then add 7 and then add 4 and then add 20. It has to be the same thing. All right. Common difference needs to be consistent across the entire sequence, or it's not an arithmetic sequence. And the last one here, to get from 8 to 3 and then 3 to -2, they are subtracting 5 every time. All right, so the common difference is -5. All right, so it's easy to find the common difference. Just subtract any two terms, and as long as it's consistent, it's an arithmetic sequence. But most of the time, in all honesty, you're going to be told if it's an arithmetic sequence. Not every time, but most of the time. All right, so it says if the first term of arithmetic sequence is a sub 1. Remember that subscript, if you watched the first video or you did any of the My Math Lab for 10.1, that subscript indicates the numbered term. So if it's sub 1, then that's first term. If it's sub 10, then that's 10th term. All right, so this is first term of the sequence. Oops, I left the T off that. First term. Each term after the first term is obtained by adding D, the common difference. This expression can be shown recursively. We talked about this word recursive in the first lesson. Again, if you didn't watch the first lesson, or you didn't do the My Math Lab for the first lesson, a lot of what I'm saying today is going to confuse you. You're not going to understand the vocabulary. You're not going to understand the notation. You're going to be totally lost because you've missed out on the prerequisite stuff already. So I'm just going to say that up front. I am recording this video. Go back and watch it again after you've watched the first video. We're done my math lab for the first section. So at least Casey, who told me she watched that video, at least Casey's got a little bit of a better footing here as we walk through this. I don't know about the rest of you. I'm just calling her out because she said she watched it. All right, so the recursive formula, get back to that. Recursive formula is a formula that allows us to find a term further down the way, like another term in the sequence, the next term or two terms there, whatever term we want. It allows us to find another term by using a previous term. All right, and so if I wanted to find the nth term here, the immediate previous term, the term right before the nth term, would be the n minus 1 term. So if n was 10, then n minus 1 would be 9, 10 minus 1. So the ninth term plus the common difference would give me the 10th term. And the 20th term plus the common difference would give me the 21st term, and so on. Again, not a hard concept. Hopefully that makes perfect sense. But what you need to be able to understand is that this a sub n minus 1 means the previous term. All right. So first example says, write the first 6 terms of the arithmetic sequence. Okay, well, that's not hard to do. If we've got a formula, the first 6 terms are A1 through A6. All right, A1 through A sub 1 through A sub 6. Well, they gave us A sub 1. A sub 1 is 100. All right. And A sub 2, actually, I'm going to write this. I'm going to do this the way I did it in the video. This is the same formula every time. So just to save some time, I'm going to copy and paste. That would be the 3rd, 4th, 5th, and 6th. All right, so A sub 2 would be A sub 2 minus 1. Minus 30, A sub 3 would be A sub 3 minus 1, minus 30, A sub 4. Why am I putting that 3 in there? Because that's where the n is. My formula here says A sub n is equal to A sub n minus 1 minus 30. All right, and so A sub 5 would be A sub 5 minus 1 minus 30, and A sub 6 would be A sub 6 minus 1. You're probably looking at this, I would be, and we're going, why the heck is he showing all that work? I know that all I have to do is take the previous term. I hope you're seeing this. Take the previous term and subtract 30 to get the next term, right? So this would be, I'm only going to show them this first one. This would be A sub 1, because 2 minus 1 is 1, and A sub 1 is the previous term. So A sub 1 minus 30 is 100 minus 30, which is 70. And this would be A sub 2, which is the previous term, 70. So it's 70 minus 30, 40. And then this one would be, oh, I left that out somehow, 4 minus 1. This would be 40 minus 30, which is 10. This one would be 10 minus 30, which is negative 20. Negative 20 minus 30 is negative 50. So the first 6 terms are 100, 70, 40, 10, negative 20, and negative 50. That's it. All right, nothing to it, not hard. I'm showing all of the mathematical details here, but really, if you were doing this on your own, I'm certain that you would go, okay, well, I would hope, I'm not certain, I would hope that you could read this and say, to find the next term, I take the term right before it. That's what this says, the previous term right before it, and subtract 30. So if I have 100, just minus 30, minus 30, minus 30, minus 30, minus 30. Done. Any questions on that? Okay, we're all good. It looks like everybody joined us. Mia came in a little bit late there. Mia, we're doing this here. You missed this. You're doing this here live because I wasn't able to get the recording to work when I tried to record this before. All right. Okay, so to step away from that specific example and just talk about arithmetic sequences using general formulas and general terminology here, meaning non-specific to a certain problem. If I had the first term a sub 1, right? If I start with a sub 1, then I know I can find the next term, a sub 2, by taking the previous term that I just had and adding the common difference d. So a sub 2 is a1 plus d. And a sub 3 would be a sub 2 plus d. I take the term right before that and add d. And a sub 4 would be a sub 3 plus d, and so on. This would be a sub 4 plus the common difference. And this would be a sub 5 plus the common difference in order to get the sixth term. All right. So if I back that up just a little bit, you'll see that in order to get from the first term to the third term, the common difference had to be added twice, right? To go from the first term to the third, I have to step through the second, which means I add d there and I add d here. So I could express a sub 3 as the first term plus 2 common differences. And I could express a sub 4 as the first term plus 3 common differences. And a sub 5 could be expressed as the first term plus 4 common differences. And hopefully you're seeing the pattern here. If I have the first term, I can just take the first term and add one less than whatever term I want times the common differences. And it gives us this general formula, a sub n, the nth term, where nth term is any term I'm looking for in particular, right? The nth term is, I'll say, any term. Usually, the nth term is thought of as the term furthest along in the sequence, the most recent term I have, or the most recent term I want, like which term furthest to the right along the sequence am I looking for? That nth term is the first term plus n minus 1 common differences. So like I said, if I want the third, then it's the first plus 2d. If that's a 3, then it's 2d. If this is a 4, then that's 3d. If this is a 5, then that's 4d's. If it's a 20, if this is a 20, then this will be 19d's. I have to add 19 common differences to the first term. All right? Any questions with that? And that formula is shown here generically. But here's the thing. I went into great detail about this in the video. I'm not so sure that I want to use up all of our time here to do the same detail. But I do think that this is a better way to think about and learn this material, what I'm about to say. I don't like this formula. This formula right here, it's too specific. This formula requires that I have the first term. There are a lot of problems with arithmetic sequences where we don't have the first term. We don't have a sub 1. While this formula demands that I have a sub 1. So I would actually back this formula up and make it even more generic and say, if I want, let's say, any term, a sub n, again, a sub n is any term, usually the term further along in the sequence. If I want a sub n, any previous term will do. I don't have to have a sub 1. If I had, I'll call it a sub k, where a sub k is, a sub k is any previous term. So if I had the 7th term and I wanted the 24th term, this could be the 7th term, which means k is 7. And this would be the 24th term, which means n is 24. And then I would just need to know how many steps is it between the 7th and the 24th. And in order to figure out those steps, it is n minus k, 24 minus 7. And I would have to add 24 minus 7, common differences. So this formula that I've written here in orange would allow us to find any term of the sequence when given any other previous term. All right. While this formula requires we have specifically the first term, sometimes we don't have the first term. Sometimes they don't give that to us. Now, the first couple of examples here, they do give you the first term, so this orange formula is not really needed. But again, this is a more generic formula that allows you to solve really kind of any problem they give you. If they give you the first term, then k is 1, and you're just looking at this formula, a sub k. All right, and the k would be 1, just like this formula shows. So it fits, it works. All right, I could have chosen any value, it doesn't have to be k, any variable, I mean. Let's practice. Excuse me. It says find the ninth term, which means they want a sub 9 of the arithmetic sequence whose first term, so they gave us the first term, a sub 1 equals 6. All right, and the common difference, that was nice enough of them, common difference is -5. All right, well, because they gave us the first term, I can use this formula that uses the first term. So I'm just going to say a sub 9 is equal to a sub 1, which is 6, plus 9 minus 1. That 1 comes from the a sub 1, right? N minus 1. So the actual term is 6, that goes here. But the numbered term, the number of the term, since it was the first term, the number goes here. All right. And then common difference is -5. I got to multiply the common differences. So it's the first term plus 8 common differences is what we're saying here. If I want the ninth term, I would just take the first term and add 8 common differences to it. So I multiply the common difference times 8. All right. Do that, that math, and you're going to end up with the ninth term is equal to -34. All right. SAT, ACT people, those of you who are juniors, you're going to take the SAT and ACT. You will find yourself using these formulas on the SAT and ACT. They are helpful for sure because they always put these sorts of questions on there. Questions on this problem at all? Everybody still with me here? All right. I'm going to keep going then. Number 3, find the missing terms. So they've given us the first term. This is a sub 1, and it looks like they gave us the fourth term, a sub 4, right? So, you know, if you recognize this one's the first term, then n is, sorry. Yeah, in this first one, n is 1, and in this one, n is 4, where n is the subscript, all right? So a sub 1 equals 17, but the numbered term is 1, and a sub 4 equals -7, but the numbered term is 4 because it's the fourth term. And in order to get to the fourth term, we had to step over twice, right? I'm sorry, step over 3 times to get to the fourth term. We had to go to the second term, then the third term, and then from the third term to the fourth term. That was 3 steps. So the common difference has been added 3 times. Now, most of you are probably going to look at this and go, okay, well, I'm starting with 17 and I'm going to -7. And they told me at the start, I didn't really say this, but it says right here, they told me that it was an arithmetic sequence. So as long as your brain recognizes in order to have an arithmetic sequence, you got to add the same number every time. As long as you get that concept down, then you just go, okay, well, what's the difference between the two? And the difference between them is -7 minus 17 is -24. And then I stepped over 3 times. So that means that that -24 has to be broken into 3 even pieces. That's -8. So my common difference must be -8. if you step over -8 every time, you're going to end up getting to -7. And so again, you would have done, let's see, -7 minus 17 equals -24, and then take that 24 and divide by 3 because there were 3 steps, and you get -8, right? That's just scratch work. That's what most of you are going to do on this problem, and that's fine. That works. There's nothing wrong with that. It gets you the answer. It's scratch work. It's not very well organized, but as long as you understand it conceptually and you're getting the correct values, I don't have a problem with that, especially in this virtual environment. And SAT, ACT doesn't have a problem with that. All right. But I do want to point out that what you're doing there, if you do that, is exactly the same thing you would do if you went back and used the formulas that I have given you, right? I'm going to do that for you now. If the formula says that a sub n is equal to the first term plus n minus 1 times common difference d, what we don't know in this problem at the beginning is d. We found it with the scratch work here. I've already given you that. But what we don't know is we don't know d at the start. So if you use the formula to try to find d, then you're going to say, okay, well, I have the fourth term. I'll put that here. The fourth term was -7. I have the first term. I'll put that for a sub 1. That's 17. And then 4 minus 1, because it was the fourth term. And then d is what I don't know. That's what I'm trying to solve. So -7 equals 17 plus 3d. Well, guess what? This linear equation requires you to do the same math that you do right here. You would subtract 17, and you'd get -24. Then you'd divide by 3, and you would get -8. So the formula here is really just laying out in a nice, neat mathematical formula the same exact thing you would have done if you did it mentally in your head. Anybody have a question with that? Is anybody following along? Or am I just talking to myself?
I'm listening.
Okay.
I'm here.
Thank you. Thank you for some acknowledgement. Am I right when I say that you guys would probably just kind of do this work mentally like that?
Yes.
Right? Using the formula is a bit of an overkill on this problem. We still haven't answered the question here, though. It asks us to give the missing terms. Well, 17 minus 8, of course, gives us 11. No, I'm sorry, 9. And then 9 minus 8 gives us 1. And then 1 minus 8 gives us -7. So the answers here are the 9 and the 1. And we've answered the question. That's it. All right. Let's move on. Number 4. Same problem. I could skip this problem, or if we were in class, I would stop and I'd say, okay, your turn. You try this problem out. But since we're not in a classroom setting, I'm just going to go through it. In this one, again, if I'm just doing it mentally, not showing a formula, not working it mathematically, you're going to go, okay, well, I start with 2. That's my first term. And I end with 0. That is 1, 2, 3, 4 steps later, or you can just count first, second, third, fourth, fifth. So a sub 0 is the 5th term, right? Well, there are 4 steps in between. So if you have to go 4 steps to get from 2 to 0, break the difference between them is 2. Break that into 4 parts. So each part is a half. Right? It's not hard to see. 0 minus 2 is -2. Then I got to divide that into 4 parts, and I'm stepping down by a half every time. So if I'm just going -1/2, then this is 3 halves, and this is 1, and this is 1/2, and then I get to 0. My common difference is -1/2. Nothing to it. But if you're using the formula, a sub n is the first term plus n minus 1 times d. You use that formula to find d, then a sub n we're going to say is the fifth term. That was 0. A sub 1 is the first term. That was 2. And then n is 5 because a sub n was fifth term. So 5 minus 1 times d. 0 equals 2 plus 4d. You'd subtract the 2 and then divide by 4, and d is negative a half. So using the mathematical formula, you get the same thing you did if you just kind of thought it through mentally in your head. All right. A lot of students are going to prefer the actual analytical steps and the analytical process that this formula is demonstrating. A lot of other students are just going to prefer to do it mentally in their head like this. I don't care, just as long as you can get it right. All right. Is there a question there? All right. Number 5. This is where the modified formula that I gave you, this formula here that does not specify that I have to have the first term, this formula right here. This is where that formula is going to be helpful because I don't have the first term in number 5. In number 5, they asked me to give the fifth term. They want this a sub 5. They gave me the 8th term and the 14th term. So I've got to kind of go backwards. I need to figure out if it is an arithmetic sequence, as they said, what's the common difference, and then go backwards until I get to it. Go backwards from the 8th term. All right, well, how would you do this? Anyone? By the way, I'm going to stop with this. I'm going to record the series conversation and post that. So the rest of these notes I will record in a video and post that. But with this last example, let's have some discussion. How would you solve this one? Any takers? Once again, we need to know if it's an arithmetic sequence, we need to know what number was added or subtracted to get to the next term. Clearly, since it's going up from 85 to 157, we got to be adding something every time. The common difference is going to be some positive number. But the question is, how do you figure out what they're adding between the 8th term and the 14th term? What are they adding every time in order to get up to 157? How do we figure that out? Nobody? 17 people in this class, not one of you can give me an idea on how to do this. All right, this is your opportunity to ask questions and get involved. Apparently you'd rather just hear me drone on forever. I'm going to do it using the formula. Actually, no, scratch that. If you're thinking about this problem, hopefully you're going, I need to figure out how many steps it is between the 8th term and the 14th term. How many times are they going to add a number? I don't know what that number is, but how many times are they going to add it in order to get from the 8th term to the 14th term? So I need to know the difference between the 14th term and the 8th term. That's probably what you would do first. How many steps is it? Well, 14 minus 8 steps. 14 minus 8 steps. It's 6 steps to get from the 8th term to the 14th term, right? 8 plus D. I'm sorry, the 8th term plus D, and then the 9th term plus D, and then the 10th term plus D, and so on until you get to the 14th term. So there are 6 steps. Okay, so if it's 6 steps, then the difference between them, the 14th term and the 8th term, 157 minus 85, which is 72. I have to take the difference and divide it by the 6 steps, and that gives me 12. So the common difference is 12. If I know the common difference, then I just subtract 12 by, oops, I meant to do that as a pointer. Subtract 12 from 85, then subtract 12 again. So if I subtract 12 once, that gives me the 7th term. If I subtract 12 again, that gives me the 6th term. If I subtract 12 again, I get to the 5th term. So I can just subtract 3D to get to the 5th term. That's how you might do this mentally. If you wanted to use the formula, then a sub n is equal to any previous term plus n minus k times the common difference. I'm using the formula to find d. So I'm going to say that a sub 14 is, let me move this down. Oops. A sub 14 is my a sub n, and a sub 8 is my previous term, a sub k. All right, that means k is 8 and n is 14. And if I come over here and start plugging into this formula, a sub n is the actual term 157. A sub k is the actual term 85. But n is 14 and k is 8. So 14 minus 8 times the common difference d. Again, this is assuming we have not done this mental work over here and we don't know what d is. We're using the formula. And so 157 is equal to 85 plus 6d. 5 didn't turn out right. Subtract 85, you get 72. Divide, you get 12. Subtract, find the difference between the most recent term and the earlier term, and then divide by however many steps is between them. That's exactly what this formula does. And we find the common difference is d, and then we know, as I said earlier, that a sub 5 is basically the 8th term minus 3 common differences, 3 steps earlier. And so that is, the 8th term was 85 minus 36, which is 49. Give me a box. There you go. Well, I'll at least get you started. There's a lot more to this to talk about the series when we start adding up the terms, of a arithmetic sequence. Then we turn it into an arithmetic series. But I'm not going to do that in this video because we've kind of already gone for a while. I will record it and I will post it to YouTube. So please watch that. You will also have this video posted to the teams. All right. Roll call. Casey, you still with us?
Okay.
Isabel. Isabel, you with us?
Hey, yeah. Sorry,
Okay,
I couldn't get my mic a second.
Drake.
I'm here.
John. Jackie.
Here.
Angelina.
Here.
Alicia. Wyatt.
Here.
Chandler.
Here.
Jahari.
Here.
Okay. James. Oh, there's Alicia. Can you speak, Alicia? Is your microphone working?
Can you hear me?
Oh, now I can. Yes.
Okay.
James, you're here. Vivica.
Here.
Mia.
Here.
All right. Catherine. Those of you who have responded, you can sign off.
Okay, thank you.
Thank
you.
Hey, Mr. Heineman, I'm here. Sorry, I was just talking to my mom.
Okay. Alex.
Here.
Kaylin.
Here.
And Trinity. Trinity, you still with us?
I'm here. Sorry, I had to keep on clicking on my mic.
Yeah, that's all right. All right, so class is officially over. Again, I'll post the rest of this video as a YouTube video and link it. Hopefully it works.
Thank you.
Thanks.
Thank you. Bye.